Okay, so today, of course, properties of special parallelograms. So when you look in your 7-4 notes, okay, you have this very lovely, I'm going to scroll it up a little bit. You have this little flow chart on there. Clearly, we have just spent a lot of time on this guy. Okay, so we are adding on today rectangle, which, I mean, I know it seems like a lot of figures, but you know some things about rectangles already. Like, for instance, what are the angles in a rectangle? Each corner is how many degrees? 90. You know that, okay? Are all the sides congruent on a rectangle? No, just the top and bottom, the left and right. So you already know some things. Rhombus. I have no idea if you've covered rhombus ever before. Rhombus kind of looks like a diamond to me a little bit. It's kind of a square pushed over. You'll see some of those. And I know you know what a square is. Okay. Okay, square. What are all the angles, all the corners in a square? 90. Are the sides all congruent on a square? Yeah. Yes, okay. So squares, you know a lot of stuff about squares. So we're going to talk some more specifics about those three today. We'll spend today, tomorrow on these three. Friday and Monday, we'll get into the trapezoid and kites, just for the record. Okay, so some properties, nothing for you to fill in. You kind of already mentioned some of these to me. So a rhombus, here's a good picture of it. Kind of, I think of it as that pushed over square. Now, key, notice they're all parallelograms. Okay, so what does that mean? All three of these already have those 5 properties on the board over there. They all have those plus some additional properties. Now, rhombus, 4 congruent sides. Now, here's how it differs from a square, because a square has 4 congruent sides. But here's where they differ. A square has 4 right angles. A rhombus does not. So that's really the difference. So that's why I say a rhombus, to me, I think of it as a square kind of pushed over at the top. That's why it doesn't have the right angles in it. Okay, you know what a rectangle is. Parallelogram and the corners, 4 right angles. So just some key properties there, just to kind of underline, highlight, circle, look at. Nothing really for you to fill in. I would just maybe do some highlighting there. Now there's this very lovely Venn diagram we're going to look at. Some people still looking at this, so I just want to wait a second. Okay, so the shading's not the best here. So obviously these are all parallelograms. They all have the 5 properties of a parallelogram. Now the fun thing about a square, I like a square. Square's my favorite. Because square, to me, I think of it as like the super polygon of polygons. It has all properties. Any and every property, it has it. Because a rhombus is a square is a rhombus. If I can underline that, maybe, come on board. And a rectangle. It has the properties of both of these. So that's the one nice thing about a square. It has everything. So kind of off on the side over here, if I can squeeze it in, I'm going to put a little note that a square is a rhombus and a rectangle. I'm going to abbreviate rectangle because I'm running out of room. Okay. So it has all of the properties. That's why I love it. I don't have to overthink it. It's got it. Diagonals bisect. Consecutive interior angles are supplementary. 4 congruent sides. It's got it all. All. Okay, so that's what we just talked about in the Venn diagram. Of course, we're going to see some corollaries that, of course, that we've already kind of specified, just some more of the properties. Of course, we already know these are parallelograms, so those apply. They just have some special properties to them. So rhombus, we've already talked about a rhombus. Quadrilateral if it has 4 congruent sides. So you need to fill in on that blank sides. Then you can flip your page. So again, remember, it still has the 5 properties of a parallelogram and 4 congruent sides. So 6 properties right now we know of a rhombus. 6. Okay, flip it. I gotta scroll it here. Okay, next page. A quadrilateral is a rectangle if and only if it has 4 right angles. So of course, rectangle is a parallelogram, so it has all 5 of those properties plus this one. It has, of course, the right angle. Now, is that something I feel like I have to hardcore memorize? No, you guys told me that a rectangle has the 4 right angles. Okay, we know that. Okay, square. If and only if, we already talked about this. It's a rhombus and a rectangle. Now again, there's so many vocab words here, so many vocab words. Now what does that mean that it is a rhombus and a rectangle? Well, what that specifically means, you know this on a square, you have 4 congruent sides. So that's the property it steals from rhombus. That's why that's there. And it has the 4 right angles. That's what it steals, of course, from a rectangle. We're just filling in the 7-4 notes, Lila. We just started. Okay. So all these fun-filled properties. Hang on 1 second. I'm going to give this to Lila. And we just filled in the parallelogram. And hang on to that. It's a gift from my heart to yours. Okay. Let's read this and see what we can figure out. For any rhombus, QRST, decide whether always or sometimes draw a diagram, blah, blah, blah. Okay, I'm just going to draw the picture over here on the side. Now, of course, key, rhombus. Now, we know my artistic skills, or lack of them, shall we say. So what I'm going to do, I'm just going to kind of steal that picture for rhombus over there, kind of my pushed over square. I'm going to kind of draw it in the middle. That's not too bad. I'll take that. I'm kind of proud of that. Okay, I'm going to label it QRST. Now remember, when you label it, it doesn't matter where you start. Like you could start Q here. Just make sure you're going in order. So I'm going to do like QRST. And again, you could have gone the other direction. It doesn't matter. Just don't skip a letter. Do them in order. Okay, decide whether statements always, sometimes, never true. All right, before we even start reading these, okay, let's think about our properties of this rhombus. You have the 5 properties of a parallelogram, which are still on the board. Meaning, I'm going to get crazy here, opposite sides parallel. Those are triangles. Bear with my bad drawing. Okay, got it? Opposite sides, are all 4 sides are congruent on a rhombus. Okay. I also know from parallelogram, opposite angles are congruent. I know consecutive angles, of course, would add to 180. I don't know if I'm going to really mark or write anything about that because I don't see anything A and B about 180, so I'm just going to kind of table that. And also don't forget diagonals bisect. Nothing about diagonals. I don't want to draw them in and make a big mess out of my picture, so I'm just going to leave it. So let's take a look at what we've got. Q congruent to S. So Q and S. Is that always or sometimes true? What do you think? Always, because that's one of the properties of a parallelogram. A rhombus is a parallelogram. Got it. Okay, Q, let's do this one in blue. Q and R. Are they always or sometimes congruent? Sometimes. They could be congruent. They could be. They don't have to be. They have to add to 180. That would be always. Sometimes. Got it. Hopefully you draw better than I do. That wasn't too painful. Too painful. I like it. I like it. Let's look at the next pictures. Classify the special quadrilateral. Okay. All right. Well, I'm going to start old school. I'm going to start with first figuring out, is it a parallelogram? Okay. Yes, that it's a parallelogram. I'm going to start with that. Now, if you remember, there's 5 ways. There was that chart with the 5 ways to prove it's a parallelogram. One of them was both pairs of opposite sides congruent, which I've got. These are congruent, opposite, these are congruent. I'm just going to abbreviate opposite sides congruent. Okay? Now, I'm going to get fancy, meaning, is it one of our special parallelograms? Is it one of our special quadrilaterals? Meaning, is it a rectangle, rhombus, or a square? Well, I'd probably eliminate square and rectangle right now because you don't have any what type of angles in the corners. Right, so those are out. Is it a rhombus? Yeah. Yes, because you have 4 congruent sides. So I'm going to put my best and final answer because a rhombus is a parallelogram that's built into a rhombus, but it has those 4 congruent sides. Now, it doesn't ask you to explain, but you know I can't help myself. I'm going to write behind it 4 congruent sides. Just for my little explanation. You just need rhombus, but you know, I get carried away. I can't help it. Okay, let's look at B. So first question. Is it a parallelogram? Yes, because both pairs of opposite angles are congruent. So I'm going to start there. Parallelogram. Love this stuff. Now again, it doesn't ask for an explanation. I'm just going to get short and sweet here. Opposite angles congruent because I'm running out of room. Now, is it any of our specialized quadrilaterals? Meaning, is it a rectangle, rhombus, or a square? Well, again, I'm probably eliminating rectangle and square right off the bat because you don't have any, as Greg said earlier, right angles, right? Those are out. Is it a rhombus? I see yes and no. Okay, I'm going to get fancy on you. Now, we already said it's a parallelogram, right? So if it's a parallelogram, aren't both pairs of opposite sides congruent? So the top is congruent to the bottom, and the left, tricky, congruent to the right. I'm going to ask you now again, is it a rhombus? Yes, because all four sides are really congruent. That was a sneaky one. And again, you don't have to explain, but you know I can't help myself. Four congruent sides. That was a sneaky one, but I like it. Okay, more properties we're going to talk about on a rhombus, rectangle, etc. We're going to talk about the diagonals now. So, rhombus diagonal. So you just have to fill in one word on the blank here. A parallelogram is a rhombus if and only if its diagonals are perpendicular. So is the word you have to fill in. Now you can see here in a rhombus, the diagonals make right angles. And again, this is why I don't know if we have time to do it today because of the short hour, but that's why I'm going to steal Greg's here. That's why I gave you this lovely sheet so we can mark everything on here so everything will be in one nice lovely piece of paper in front of our faces. Okay, more rhombus properties. Opposite angles theorem. Okay, parallelogram is a rhombus if and only if each diagonal bisects, we're going to fill that in, a pair, and I'm going to underline something too on this, opposite angles. So that's on the next page. Flip it if you haven't. Flip it towards the top. And I'm getting excited to actually do some real math. Okay, so let's just kind of get specific about this because I feel like people see the word bisect. And I mean, this is true on the rhombus because it's a parallelogram. The diagonals bisect, yeah, but that's not what we're talking about. We're talking about they bisect opposite angles. So notice not only so many good things here in a rhombus, the opposite angles are congruent, but they're also cut in half equally. So if I know this side, you automatically know the other side to it. So the diagonals cut the corners in half. So we're going to use that here in a minute. All right, let's find some angles. So find each numbered angle in the rhombus. Okay, I'm going to start with the easiest one. Number 1. Diagonals on a rhombus are perpendicular. So I don't have to do any work. I'm just going to say measure angle 1 equals 90. Got it. Like it. Piece of cake. Now, here's where we got to get a little exciting and use some old school knowledge. Meaning, if you know this angle's 61, I know this one's 61. Why? What type of angles are they? Alternate interior. Good. Okay. I'm just writing it nice and fancy. I don't care if you just label them in the picture is fine too. Like if you just write up here 61. I just get carried away, as always. Now, of course, I mean, I'm just doing them in order here as you can't figure it out, right? I'm going to do 3 next. Now, guess what? If you know 2, you know 3. Because that is that last little property we looked at. They bisect opposite angles. So those corners are equally split in half. So if this guy is 61, this is 61. I can just copy it. Okay, all right. Okay, that was one of our new properties. Now, 4. Oh gosh, okay. All right, we can do 4, I got it. Now look at, you've got a very lovely triangle in here. You know this. All angles in a triangle add to what? 180. So here's where you might need your calculator. So I'm going to do 180. I'm going to take off the right angle. I mean, you can mental math that part. And then let's take off, of course, the 61. So what does that leave you with for angle 4? Good. Love it. I'm just going to write it over here so it looks pretty. Okay. So not a lot of work needed, like that stuff. You try, everybody done writing? You try this picture. So you can get me the angles. I'll give you a minute. Let's see, I'm gonna do these a little out of order, and I'm gonna start with the easiest one. I always start with the easiest one, right? I can get to this one with no work. What's 3? 90. Diagonals are perpendicular. And I don't care if you list them out of order. That's totally fine, okay? Now, other things we know, right? If this is 38, I know this would be 38, even though that's not one they ask you for, but hang on, it's gonna lead me to one. First question though, why is this guy 38? Alternate interior, okay, that's great. Now, of course, if this is 38, here's where we're at. I know this is 38. Because remember, the diagonals split the corners in half. So I now know angle 1 is 38. And again, I don't care if you list them in order or whatever, okay? So let's do 2 here. Now again, remember, these are all right angles in the middle. So I'm zeroed in on this very lovely triangle for angle 2. So all 3 angles should add up to what? 180. So to do angle 2, I mean, you know, we can take the 90 off in our head, right? So what's 90 minus 38? 52. So I'm gonna put 52. It's kind of like a puzzle. I love this stuff. And you know what? 52. I can tell you what 4 is now with no work. 52. Because remember, on a rhombus, the opposite angles are congruent and bisect. So just, I know it doesn't answer all these, but I'm getting carried away. That's 52, 52. And then these are congruent and also cut in half. So these are all 52s. It's like a big round of 52s on everything, even though I didn't have to answer all that good stuff. Hey, more properties, more properties. Okay, here we go. So rectangle, diagonals. We've done a lot with rhombus. Let's talk rectangle, okay? So a parallelogram is a rectangle if the diagonals are congruent. So that is the word you have to fill in on the blank there. Now don't flip the page yet because we have to answer something at the bottom. But, okay, so many things to point out here on a rectangle because it is a parallelogram. I feel like Vanna White over here on the board. So of course your diagonals bisect, which they have the tick marks on them here. So this is from your parallelogram properties, but they're also congruent. So this whole thing DB is congruent to AC. So the whole lengths of the diagonals are also congruent. That is also one of the key specific properties of a rectangle. Okay, so before you fill in the next thing, just read this. Okay, notice there's no theorem specifically mentions diagonals of a square. Why is it? Well, because a square is a rectangle and a rhombus. So the diagonals of a square are also congruent, okay? So I'm just gonna put congruent here. You can just draw the symbol. And remember, I love a square because it's a rectangle, it's a rhombus, it's a parallelogram, meaning it has all the properties, all of them. It's got them all. It's got them all so far. Makes square easy for us. Okay, this is just flag. All right, here we go. Let's actually do something with math, right? Okay, first off, determine the type of special quadrilateral. So is that a rectangle, a rhombus, or a square? What do you think? Rectangle, rhombus, square. Square. Now, I know it doesn't say to explain why, but I can't help myself. It is a square because you have 4 congruent sides. And, because a rhombus has 4 congruent sides, why is it not a rhombus? It has 4 what type of angles? Right angles. That's what distinguishes it from a rhombus. And again, don't get like carried away on like, oh my gosh, there's so much to remember. You know what a square is, people. It's a square. Okay. All right, solve for x. Okay, well that's easy. So I see x is on the sides. We know all the sides are congruent. I'm just going to set it equal. So 2x plus 1 equals 4x minus 7. Let me give you a second to solve that. Easy peasy. 4. Okay, you don't need me to do the work. We got it. Okay, let's do y. So I'm looking for y, of course. Y is this lovely angle here. Now, all right, okay, we got to get smart here. They don't give you really a whole lot of info, but they do. They do. Because remember, your corner is a right angle and diagonals bisect it. So what's half of a right angle? 45. So I know that 7y plus 3 should equal 45. So that's where I got the 45, because it cuts that corner in half, the diagonals. Okay, solve it. What do you got? 6. Okay, home stretch. You know I love these problems. So of course we're filling in, notice rhombus. We're filling in all this stuff. Now, before I do the picture, I'm just going to get carried away and mark, before I get through the A, B, C, D, I'm going to mark everything I possibly know in the picture. Here we go. If this is 7, I know this. What's ED? 7. Easy. I also know all of these angles in the middle are what type of angles? Right. Okay? I also know the sides are congruent. If I needed anything about that on my rhombus. Now I see over there on the list of stuff, obviously, there's a lot about angles. Okay, well let's fill in as many angles that we can. If this is 34, what's this one? 34. Now you should also be able to mark another pair of 34s. Because remember, opposite angles are congruent and of course they're bisected. Or really, these are the same. Okay. Now I have a feeling, because we have a whole list of angles over there, I have a feeling we might need to get like these guys over here. Okay, I can do that. I'm going to use some old school knowledge. I'm just going to look at this triangle. All 3 angles in a triangle for the 50 millionth time add up to what? 180. So let's just do quick in our calculator. What's 180 minus the right angle? We do that in our head. Minus 34. And I already heard it, 56. So you should be able to fill in 3 more 56s. Fill them in. Okay. I have like everything I could possibly label on this picture. So we should very easily, I'm going to try not to scroll it off the screen there, be able to fill all this stuff in. So I think we can. All right, we got it. BD. Okay. What's the length of the diagonal? 14, 7 and 7. I like when I don't have to do any work. Okay, angle. B, got it. C, got it. E. Oh, yeah, right there, my purple 34. I'm going to try to scroll this up just a little so I don't get it off the screen. Okay, CED. C-E-D. Light work. It's in the middle, it's 90. This is so easy. Okay, BAD. B-A-D. So that whole corner is what?
90.
Whole corner. 68, 34 and 34. All right, C, I should have worn taller shoes. B-A. So what is this whole corner? 112, 56 plus 56. Got it. And our final one, I know the yellow doesn't show up the best, but it's going to be good to highlight it here. C, B, E. Don't I clearly have it labeled? What's CBE? 56. That's a 56. I hope you can see it okay. Parker.
Oh, you're missing angle B.
Oh, am I off the bottom of the screen? I need a bigger screen. Sorry, Parker. What's D? CDE. Do I have it over there? CD. Yeah, you got it. Sorry, guys. I need a bigger screen. Can you see the yellow okay? I hope they're... All right, any questions on that? Okay, are you ready for this last problem? Oh, boy. Right small. Okay. Determine whether the quadrilateral blah, blah, blah is a rectangle, rhombus, or square. Okay, all right. Okay, let's do it. Let's graph the points here. -2, 6. A. B is at 6, 8. I'm just plotting the points. I'm not doing anything great here. 8, B, 4, 0. That's a C. That's a sloppy C. And -4, -2. Got it. Okay, let's connect them. See what we got. Now, just off the cuff, just looking at it, what does your gut instinct tell you? Is it a rectangle, rhombus, or a square? I'm thinking rhombus, right? But, but, of course, we're going to have to justify and explain with work our answer. How do you know it's a rhombus and not a square? What's the difference between rhombus and square? They both have four congruent sides, it's the right angles. So the first thing I want to talk about, okay, this is going to be easy to prove it's not a square because we don't have right angles in the corners. So again, perpendicular right angles, I could do a slope, okay? So I'm just going to pick one of the corners. I'm not going to get crazy here. I'm going to count the slope on AD. I should say you're going to count the slope. Okay, so I'm just counting the slope D to A. Count it for me. 8 and then over 2. And you know I love to reduce. We should always reduce, okay? Now I'm going to count the slope from A to B because I'm looking at that corner right now. Okay, A to B. Up 2, 2, 3, 4, 5, 6, 7, 8. Okay, up to, let me write it here. Up to over 8. I'm going to reduce. Now here's a throwback to chapter 3. The slopes for perpendicular have to be reciprocals. Those are reciprocals, but they also have to be opposite in sign. One positive, one negative. If that was a negative 1/4, yes, it'd be perpendicular, but it's not. So I'm just going to put a little note, not perpendicular. You have to have, of course, opposite reciprocals for the slopes. Okay, so I showed that, so that's a winner. Now, gosh, we're not going to get crazy today, because plus I'm running out of time. Yeah, we are running out of time. So here's the other thing. If I needed you to justify that it's a rhombus, that you have four congruent sides, because let's talk about this, because we saw a little bit of confusion on our quiz yesterday. If I want to prove to you it's four congruent sides, all those sides are the same, 50-50 kids, would I use slope or distance formula? Oh, good Lord, I'd have to do distance formula. How many times? 4. Okay. Does it say that I have to justify today or explain in the no, but I just wanted to point that out to you. If I had to justify with work, I would do distance formula for that. Nobody wants to do that. Okay, so here's what I got. I got something different for you for homework.